Ondora, I think we can start.
So good evening, everyone. I hope you can hear me. Can you hear me?
Yes, I can hear you.
Okay, thank you. So I welcome you all to our today's presentation. Today is 27th of July. So we have been having a presentation on PVC, SketchUp, and AutoCAD. So I welcome you all to our today's presentation. So we are doing this free training so that to welcome you to our 3 weeks training that will be taking place as from 4th to 22 of August. And the cost is 60 USD. So today, Engineer Aziz is going to take us through how to design a solar system using PVC, SketchUp, and AutoCAD. My name is Engineer Ondora Mogere Dalton. I am a technical engineer. My specialization is in solar technology, and I have around 3 years of experience in this solar industry. So at this moment, I think I will welcome Engineer Aziz to take us through the presentation. So if you could be having any question, feel free to chat in the chat box. Yeah, thank you so much and welcome Engineer Aziz for the training.
Thank you, Mr. Ondora. We all welcome all of you into the training session. Uh, my name is Azizul Hassan. I am basically from Pakistan. Most of the people have joined us in the previous webinar. I have 6 year experience in designing field of the solar systems. So today I will briefly explain what are the main uh, steps do you follow to the PVsyst, AutoCAD, and SketchUp. We will start from the PVsyst software. Where how can we develop a solar systems? I will share my screen. Can you see the screen here of the PVsyst software?
Yes, we can see.
Basically, the PVC software is, we have explained in the previous webinar that the software we are using for the energy simulation and to get the estimated number of the energy units which we will we generate from the solar systems, and also the performance ratio of the solar system. The basically the performance ratio is that the ratio of the irradiance we get from the sun and how much energy we get from that solar system. Basically, this is the performance ratio. In this webinar, I will briefly continue with the uh, project, how to design on the PV system. First of all, you see there are the interface of the PV system, in which there are the 6 options in that PV system. One is for the grid connected, the other one is for the standalone, and the third one is for the pumping. Basically, the grid connected is without the battery systems. Standalone is with the battery but not grid connected. And the pumping system is we usually for the irrigation purpose. And the next interface is for the utility. In that is the database where we get the the all the PV modules, the other inverters, equipment in the database. The tools we are using for the measuring data. First of all, we start from the grid connected systems. Basically, we are designing the grid connected system. So that's why we click on that. Uh, you see that there are, this interface is open in front of all of you. First of all is the project name. The other one is the site file, and the third one is the weather file. Basically, there are the option is available from the up. It is the project I have already simulated in this project file. Now I will start with the new project in which we will give the name of the project, like we give the test project, and then this is the project name. The other one, there is the side file. We have to give the location of the project. We add new side here. I give the Lahore location where basically when we are simulating our project, we give the correct coordinate of the site. Here I am just uh, you guide through the how we simulate the system and how we give the input to the simulation software. But when you are actually doing the project, you will give the coordinate system. You will give the latitude and in the locality search box. Now you will accept this option, select this option, and you see that they give us the locality Lahore, country Pakistan, latitude and longitude, altitude and zone. When you are simulating your project, you will see your project location. Like here is the location, country name, latitude, longitude, altitude, which the PVsyst get from the his database. Now you accept. When you accept this, they will give us the site name, country, the region, and the longitude latitude here. You see that there are the multiple weather import files. What is the metronome, then NASA PVGS TMV file, and NRGL TMV files. So metronome basically it is the satellite based data and ground database. It is the mixture of the where we get the weather data. This is the basically metronome is the uh, department. They will get the data from of the weather through different positions. So that's why. And the other one is the NASA. You all have know the about the NASA. They will also get the weather files and the PBGS file. Uh, it is also an department which get the data of the weather file. So in this way, if you have PVGS file from the client side, you will select this. If you have NASA file, you will select. But here I have no jet file, so that's why I have selected the Metronome files. And then you should just import. They will take time, and they will give the data of the file. The global horizontal irradiance, horizontal diffuse irradiance, temperature, wind velocity, turbidity, and relative humidity of the side. So now irradiance unit is basically kilowatt hours per meter square per day. So that's why we have selected this, and then we select OK. They will save us the location, and we will select this. Yes. You see that there are the weather data of the metronome is selected here and the location is also here. So just you have to save the files, and then variant name. Variant basically we can develop a different variant of the software the project. So that's why we give the number name. It is the first variant. So then we will see the orientation in which give us how is the azimuth of the side, how is the plant the tilt angle of the PV module where you are installing. Like that, I have selected 30 default and then go to the OK. And in this is the system definition. Basically, in that we will define the capacity of the system. Like we have the 30 kilowatt system, and we select the uh, PV module and the wattage of the PV module, and then we will go down and we select the 600-watt panels, and then there are the inverter selection option. You have the option like the Huawei. You should see the from the drop box. There are number of the manufacturer are available. You can select any of which you have been selected for the your projects. So I have selected Huawei and then go to the power of the inverter, and I have selected the 30 kilowatt inverters. You see that this is they give us the option the as per the temperature given from our side, they give us the option from the number of module minimum and maximum for the string sizing. So they give us the 6 and 18. We have selected 13 number of modules in the strings and 4 strings for our projects. So they give us the number of strings. And here you can see that if you are just using one inverter, you should uncheck this option, use multiple MPPT features. But if you have the different orientations and different number of strings option, you can select this option and you see the MPPT. You can see from the data sheet of the manufacturer of the inverter, they give us the number of the MPPT of the inverters. So you can check that how many strings on one MPPT we can select, we can put on. So here we can use this MPPT. And I have just used the one inverter, so that's why I have unchecked this option. And now I will go for the OK options. You see there are the number of other options available in there. One is for the detail losses. I have explained in the previous webinar that the detail loss is a very critical point of the PVC softwares. So when you are simulating the software, you have to come out through the proper calculation for the detail losses. First is the option for the thermal parameter. Thermal parameter we can select from this checkbox. One is the free ground mounted probably air circulation, where we are installing in the ground mounted system. There are the circulation of the air is available. So that's why if we select this option, they give us the 29 watt per meter square Kelvin. And the other one is the domes. Dome is option where the circulation of the air is not in the proper way. So that's why they give us the 20 C factors. The third one is the semi-integrated air duct behind. If any duct behind the PV modules, so you can select this option. The other one is the with the fully insulated bags. If you can install the PV module on the shed mounted structures, then you select this option. But here we are selecting the ground mount system, and I have go with this. The next option is the ohmic losses. This is the very critical part. Here we can need the cable sizing of the option. In the previous webinar, I have explained how to we do with the cable sizing. Here we can put the losses of the DC strings, AC cable losses, MV cable losses, transformer losses. Here all we can select that options. Here first one is the DC ohmic losses. DC ohmic loss basically the string cable loss we select here. Here is I have selected 1.5, but basically it is between 1 to 1.5 from the IC standard, and we put on as per our calculations. Now check on the use AC cable output ohmic losses. Here you can see that the length of inverter to the injection point. The cable of where we use the AC cable from the output of the inverter to the injection point where we are using the AC cables. And from there we can select the length like the 30-meter and the cable size where we are using the copper, aluminum, which one we are using like 16 mm square. We see that they give us the ohmic AC ohmic losses. Now you can use the MV cable also. Here we check that option and see that the medium voltage losses length and it's, but in our case the cable system is 400 kV, so there is no ohmic MV ohmic losses. So we select their number of the for the big power plant like the 30 megawatt, 10 megawatt, we have to select the MV transformer, and we have to use this option for the data sheet and give us the ohmic iron and copper losses of the transformer. Uh, Ohmic basically due to uh, the the impedance reactance of the transformer, and the copper is the from the resistive losses. So we have to put this from the manufacturer data sheets of the transformer, and also we put the voltage level and the meter of the cables. So here we can uncheck this option and see this option. Now we move to the next option. This one is the module quality loss, is the basically the losses appear in the our PV module. One is the module quality loss. Basically, it is for the average. You see that here is the question mark there. When you select this, they will explain how to module quality loss. It is between given from the manufacturer. They give us the module quality loss, so we will put this option here. But from our point of view, we have to if the manufacturer give us the, if the this option is negative, this is the positive, it will add in the module quality, and if it is positive, then it is negative from the quality of the PV module. So we will put this from the PV module manufacturer data sheets. This is the LED loss. This is basically the PV module loss when they expose to the sun first time. They will degrade some percentage of the power loss power. So that's why they call as the light induced degradation factors. So they will give us give from the manufacturer also. This is the module mismatch. It is basically the mismatch between the current of the different batches of the PV modules. When I will go with, in the paid training session, I will explain one by one how, because there are the time shortage, so I have to just explain that we will give this as 0.8%, and what we get this from the module manufacturers. It is a basically the last one is the option is a string voltage mismatch. String voltage mismatch it is the highest string voltage drop and the minimum. When we are connected on the 1 Mbps, we check how much is the difference between the maximum voltage drop and minimum. So this is the voltage mismatch. Now we move to the soiling loss. It is basically the dust will appear on the PV module, and we don't clean the PV module. This is the loss appearance, and it is usually vary from the different region of the where we are installing these solar systems. So here in the Lahore, there is a lot of dust present. We put it 3%. This is the IME loss. Basically, it is the loss in the PV modules when the rays strike on the PV module. They give us the output, and at what angle and what angle they strike on the PV module. This is the basically IMA loss, and we will use the definition of the PV module. It is mean that the manufacturer give us the this incident angle, and we will import the pan file of the PV module. We just check this option, and they will get from the module manufacturer pan file database. The third one is the auxiliary losses. This is the losses where in this small system, basically it is not used. For the large power plant, our system is running in the night system due to the war compensation and then any other issue like and in the day consumption, they will give some power from the our solar system. So that's why we have to put these losses in our calculation. The third one, this is the aging factor. It is basically for the module which is degraded over the year. Like at the first year, they will degrade 1% for the N type, and from now 2 to 25 year, they will uh, uh, degrade from the 0.4% the PV module power. So we have to put this also, use this, and they will give us that. And the one last one is the unavailability. This is the unavailability systems where we are using that the system will unavailable for the due to the some reasons. So that's why we have to put the percentage loss in there. Then we click on the OK systems. Now we can, this is the main parameter we will use in the simulation purposes. Now we will run the simulation report. You see that we have get the report of the PVsyst software. You see that they give us the performance ratio, like the 78.94 is the performance ratio, and the first year uh, module, they give us the units for the specific unit which we get for the first year. The whole for the 25 year, they give us total number of units per year. So this is the report we can get from the software. When we will go in the paid training program, I will explain every point of view in the simulation. Here I have just give the overview of how to we will simulate our design in the PVsyst system. Now I will just move on to the next software, which is the SketchUp, because there are the time shortage. And if you have any question at the end of the session, I will explain your questions. Now I will move to the uh, SketchUp software. You can see the screen of the SketchUp.
Yes.
Yes. Here is the
Yes, we
sketch.
can see.
Yes. Okay. Okay. Here is the SketchUp. I have designed last night. This is my client projects, and I will give all of you a small intro of this project. This is basically the 300 kilowatt system, and this is the high res structures we have. I have established on the SketchUp software. You see that I have built the gutter system and the foundation of the systems, and also the PV modules. Here is the line. You can see that here we can use this in the red axis. You see that I will give some option like the 5 meter. It is the green. I'll give the 5 meter. You see that? Can you see?
Yes.
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 Yes. This is the option of the push pull option. You see that they will appear push pull, in which when we select this option, they give us the height of the our buildings. Like there are the 30 feet height. So I will select the 30 feet height of the buildings. Here is the height. Now I want to place the PV module here. Just I have to click on the this building, and we will go there. You see that this is the scallion option. It is the basically uh, built-in extension of the SketchUp file. You can place the PV module through this option. Just click on insert solar component. They give us the options for the azimuth tilt angle, relative tilt angle, the modules which we are selecting, and the option where we can place the modules in the portrait, landscape, and the pitch of the software. Just I have selected the 15 tilt angle. The module is already selected from the database, and this one is the landscape, and I have select the 2 1, and I have give the pitch as a 9 meter. So just when I've clicked, so there is the issue is that the building is short enough. So no, you can see that they will place the PV module here. So when you have selected this option, you can place the PV module here, and then after that, this work like this, the this work, the structuring work, we have to develop this structure as per our project requirement. We can place the PV module from the extension, but for the structuring of the PV module, you just have to build manually, like that. We have to select number. Here we can build the girder, the C channels, like that. I have built this C channel, the girder, the foundation. A foundation is a simple, like just we give this value, this, and this, and then we just give the push pull. Just this build the foundation of the structure, but it is as per your the solar system requirement. But for the main structuring purpose, like this girder system, you just have to like girder is the 5 by 20. So I give 5 inches by 2.5 inch, 2.5 inches by 5 inches. Now I will. This is the option of the offset. Offset. I have moved this 2 mm thickness of the girder. I have selected this. They give us the center of the file. Now I will give also 1 mm thickness inside and one for this side. Just connected this. Now I will use the erase factor. I have to join all the option at the end of the building. Now you can erase the options. You see that we will make it as a component. Basically, the component is the the uh, the function. When we will this option, we will give the push pull factors. They will prepare the girder. We will make it as a component. Just we have created a component one, and I will copy this option. You see that when we will change in one component, like in this, I will give the height to this function. they will automatically in the same component, they will give us the height. So we have to make the component in the project formation. So basically when we using the same pole of the structure and the beam of the structure, we will give the same component name. So we have to make this as a manual function, but we can place the panel through the extension. And also I have this option of the fence, where in the ground mounted system we can use the fence system. So I give this, you see that, they give us the fence of the structures. This is also through the extension. So basically, this is the main, and this is the option is the shadow analysis. You can see that the month is selected as June. It is the December in the Pakistan. Is the highest month of the shadow, and you see that they give us the shadow on the mountain structure. So that's why we have to give the pitch higher than this, because this pitch creating the shadow on the back PV module of the from the to the front, and also from the this uh, fence. So this is the main purpose. I will show you how to place the PV module, how to give the shadow analysis, and how to make the different component, and how to install on that component. This is the main overview of the SketchUp software. And now I will move on to the AutoCAD file, and I will show. This is the project I have developed for my client. It is a 15 megawatt project. You see that this is the main interface of the PVK software. Basically, I want to give you the overview of just the PVK of the software. It is basically used for uh, the uh, the layout making formations, and there are the multiple options. We can draw the road, civil analysis, we can terrain mesh options, and cross section view. And electrical view, we can calculate the length of the cables through the PVK software. Uh, so I will just create a rectangular file. You see that, and now it is the frame options. I will select. Here we can select our frames, then the number of the modules, width of the module, thickness of the PV module, power of the PV module, and the framing option. It is tilt angle, fixed tilt, it is tracker based, it is east west. So we now move on to the fixed tilt structure. The PV module orientations, they give us the option for the landscape and the portraits. So we move on to the landscape and the number of the rows. You see that there are the four number of rows, four PV module in the one stack in the landscape formation, and we give us the two formations and the number of the columns. Basically, number of column in how many PV modules in one column. So they give us the 10. We give through the 10 options. They give us the short our structures. The tilt angle 25-degree, horizontal spacing between the PV modules. They give us option. So this they will just default. Okay. Now I select these options and go to the single just area, and they give the option that select the object. They give us the option to select the PV area polyline. This is the PV area polyline, and now they give us the oh, basically they give us the option of the terrain options, because they are the selected in the terrain options. I go through now and other options. I've closed this option. There are some issue in the AutoCAD files because the PV case is the crack version, and when the internet is going on, they will get crack. Due to that one, they will not show us the AutoCAD files. That is the main issue. So the issue is that we are going, Mr. Andora. There is the issue. I can't connect the internet session in that in the sessions. So just the issue is that when we are using the AutoCAD files, they don't allow us these options in the internet. Now I'm just opening the AutoCAD files to explain how we can. But for the PV case, in the next session of the paid, I will explain every point of view. But in the AutoCAD, I will just explain how to we just build a PV module manually in the AutoCAD. Can you see the screen again?
Yes, yes.
Uh, Basically, I am explaining about the PV case, but the issue is that sorry for the terms due to the internet issue. The issue internet is going on. The PV case when we are starting the PV case, just we have to uh, shut down the internet, and then we will add the PV case. After adding PV case, we just on the internet. But here I can't disconnect the internet, so I can't explain PV case. But in the manually, I will explain how to we can build a PV module. Here is the option. You see that I have selected the rectangular command in the AutoCAD, and here the it is in the meters. The length of the most of the module is 2.3 382, and the width of the module is 1.303. It is a basically it is a small PV module. You see that I have built it, and you can just select this option and CP for the copy command, and you just select this option, select from that, and just here. When you Just select this option because it is a manual function. Now you can uh, make it to the three piece like that. It is the structures we can copy, make them. So this is the basic structure. We can group these structures, make it as group, and just rectangular this mark for the buildings area like that. And we will copy these options here. At what pitch you are placing angles like that, here like that. You can place the number of the module structure as per your project requirement, and at what pitch you are requiring. Pitch is basically, I can explain pitch. What is the pitch? uh, I can realize command for the length. This is, it is the pitch, basically the start of the front structure to the start of the back. It is the total area. It is the shadow free area where we are not placing the. This is called, this is called just row spacing between the mounted structures, and this one called the pitch of the structure. Mostly we can select from the center of the front structure to the center of the structure. Back of the, you can take this option from the front, back to back, or center to center, or from the front to front. It is the total area. It is called the pitch, and it is called the the row spacing between the mounted structures. So you can add this type of the structures here. For the large scale projects, you can manually do that. You just make this one group and place as per. Here is the option I have modified array. It is the array options. Array option is basically we can make array of the structures. Uh, I can make an array for your easiness. If you are doing the manual mounting structure, PV module mounting, you can just select these options, go to the these options. Yeah, or you go with the command, then you can select the AR. AR is for the array command. They give us the option rectangular, path, polar. Path, they give us, you give us the path. For the polar, it is the polar lines, and for the rectangular, they give us the back, and uh, you just select this option. You see that they give us the options. They